Hey, you guys, Miss Morell here with your recap of science instruction from last Wednesday and Thursday, March 3rd and 4th. And woohoo, we are almost to spring break. Can you guys believe it? Um, okay, so real quick, I want to take a second to recap the learning targets for you. We have been talking about biodiversity now for quite a few weeks. We talked about it when we talked about parts of an ecosystem. We talked about it when we talked about food chains and food webs. And now we've been talking about it in the context of ecological succession. So remember, biodiversity is when an ecosystem contains a wide variety of organisms. The more organisms that are there, the more adaptable the ecosystem is, the more that it can bounce back after a disturbance event. So, biodiversity is a wide variety of organisms. Biodiversity helps an ecosystem maintain its sustainability. So, sustainability is the definition. The definition is an ecosystem that can keep itself going. It is sustainable. It will keep itself going without any outside assistance. So, in an ecosystem, when there's no human interference, the populations, there are certain limiting factors that keep populations in check that help maintain balance in the ecosystem. And the more balanced it is, the more sustainable it is. So biodiversity, the more biodiverse, the more sustainable. When we talked about food webs, we talked about how when you take an organism out of a chain, the whole chain breaks down. But in a web, when you take an organism out, yes, there are effects on the other organisms around it. And yes, there are ripple effects throughout the web, but nothing breaks down completely, and those organisms can adapt. So we've talked about how restoring organisms to an ecosystem. We watched the video about how wolves change rivers. That's a positive example of biodiversity. So by introducing a single species in the Yellowstone ecosystem, biodiversity began to reestablish itself. And the more biodiversity became, the more healthy the ecosystem became. We've been talking about ecological succession. We know that ecosystems change over time. We know that they can repair themselves after being damaged. So we have two kinds of succession. We have primary succession and secondary succession. And secondary succession or primary succession would be after a disturbance event like a volcanic eruption or some other event in which there is nothing left, not even soil. And this kind of ecological succession takes a lot longer because soil has to be made first. So the first organisms to come in will be the pioneer species that make soil. And so those are going to be very small lichens and mosses and things like that that attach themselves to rocks and then slowly begin to break down the rocks and create soil. And then slowly but surely, seeds will take hold and plants will begin to grow. And then you'll have organic matter in the soil. And then the healthier the soil becomes and the more of it there is, then small plants and grasses will come in and establish themselves. And with them will come small animals, insects and burrowing animals and things like that that make grasses and small plants their homes. And then once that soil system is stabilized, then you'll have larger plants come in. Larger plants, trees, shrubs. And when you have those plants come in, then those organisms that make their homes in those plants will come in. And then finally, the ecosystem keeps evolving until it becomes a climax community of mature hardwood, slow-growing trees and the organisms that use those for their habitats. So ecosystems absolutely change over time, and that process is called ecological succession. Primary is when there's nothing left, not even dirt. Secondary is the same process of succession, but dirt does not have to be made. So, for instance, after a forest fire, you would have secondary ecological succession because the dirt is already there. It doesn't have to be made. And so, obviously, secondary ecological succession is a much quicker process than primary because dirt doesn't have to be made, soil doesn't have to be made. Things can just start growing right away. But the rest of it is the same. You got to have the small stuff holding the soil in place and those organisms that live there before you have the big stuff. So it goes small to big in ecological succession. So primary, secondary succession, we've been talking about that. Here was the agenda. There was a video recap. We did our warm-up questions. You guys know how much I love Amoeba Sisters, so we watched another Amoeba Sisters just to kind of summarize the feeding relationships, predator-prey. We touched a little bit on symbiosis, first, second, third level consumers, etc. We took a quick look at the related journal pages. We did a Kahoot of feeding relationships, and then viewed an ecological succession presentation. So then I asked you to complete your March 1st through 5th homework. There was an explanation video. B-Day students spent some of their time doing their Unit 14 summative retest because last week was an A-Day, not a B-Day. We needed to get it done before the end of the term. And then finally, you had a virtual lab. We took a Kessler-style lab and put it online for you and asked you to complete that. And then your Unit 15 summative quiz, 15 and 16, is coming up today and tomorrow. So it's Monday, March 8th and 9th. So we asked you to study for that. All right, excellent. If you have any questions, please see your science teacher. Have a wonderful day.